Hey guys, welcome back to the channel. So I've been dealing with a breaker that keeps on popping after my unit has ran for like 30 minutes to 45 minutes, and this has started happening about 2 months ago when it was running in heat pump mode, when it was getting really cold, and this thing was running in reverse down here in Florida. I've been trying to diagnose it all this time, but now I finally got it right. After messing around, it ended up being the breaker. So we'll go over everything I diagnosed and how I came to that conclusion in this video. My house has this meter right here where you actually have access to the bottom of it because there's a breaker panel in here. So what you do is you just go ahead and pop this thing up, flip this thing all the way in, and then you can pretty much slide this thing down and open it like that. In here, you want to disconnect your main power breaker right here. This disconnects it from the utility and everything, and you'll de-energize the house to work safely on the panel. Inside the house, there's going to be 6 screws all the way around. I've already been inside of here, so I took most of them off. I'm just showing you guys right now what to do. So you take all those off, and this panel just pulls right out and gives you access inside to do all the wiring and see what's going on behind there. But remember, make sure you disconnect the power outside so you don't accidentally touch the lugs in here. What the back side of the panel looks like right here, that's the cover part that basically covers all the breakers, so you don't see any of the wires behind it. It's kind of a flexible piece that moves around, but once you take those 6 bolts out, this thing just pops right off, so be careful it doesn't drop on you. One of the tools I've got a couple years ago with these little bits right here when I was doing switches and then anything electrical. So what it does is basically a flat head that has a square in the middle that basically fits all the lugs right here on the actual breakers. It fits the screws inside switches, and then it also fits these screws right here for the panel that have, see that little square in the center? So that tip is designed for that. These things are very useful for electrical work if you guys need them. I think they're called ECX bits. I'll link them down in the description if you need them. They're pretty cheap. I think I got 2 of them for $5 off of Amazon. On the panel, you've got the 3 main power that comes in. That would be the 2 sides of the 120 that makes 240, and then the neutral, which is white, and then those basically go down the bus right there, and that's what all your breakers connect to. For this repair, I already made the change, but what happened before was this thing kept on popping. This is my AC breaker right here. Every time the unit ran for 30 to 40 minutes, or when it kicked off, it would break. And then I was trying to figure out what the hell is going on, because if this thing keeps on tripping and you turn it back on and it works, obviously there's an electrical issue somewhere that you got to diagnose. So this happened when it was cold here in Florida, so I just popped it a few times and then it didn't really come back on until we started cooling again now, and then now it just pops every single time because we're in cooling mode, and this thing runs pretty much every hour on the hour. So part of my diagnosis out here was basically first disconnect the power so you don't have any power coming to your unit. What I do is basically just pull this out because I have this disconnect here, so that cuts power right there. And inside here, I've got my CT right there that measures the amps and the electrical consumption of this thing. So that's just part of my smart home. So that's how I monitor and know what's going on with the unit, just in case there's any troubleshooting. That's just a side benefit of having this. So when I originally looked in here, I took the thermal measurements when this thing was running, so everything in here was fine. It was running around 90 degrees Fahrenheit, so none of this wire looked like there was the issue here. Everything was free flowing through here. On the air conditioner side, you basically have to take apart this cover right here to see what's going on behind here. So you unscrew that, the 2 right there. You don't have to unscrew these top ones, they're just in there. You loosen them up so you can actually just slide this thing down. So in here, the first thing I did was I checked my capacitor. This one's actually a new capacitor. I swapped this out thinking it was the issue, but it's not. I had a better, more robust capacitor in here before, but that thing's going on 6 years now. So I went ahead and just changed it in case this thing went bad when I'm not home and my wife doesn't have to deal with it. I'm keeping that other one as a spare for now because it was still testing as fine, even though I just swapped it just in case there was something wrong. And most of the time, if your fan is not running or your compressor is not running, and this thing is more than 5 years old, 90% of the time it's the capacitor. You want to go ahead, look at it, see the numbers on the side as a farad. So there's going to be two numbers. There's going to be a big number and a small number. Mine on this unit is 70 and 7.5 microfarads, so that's the rating for mine. So you have to order the exact same one off of Amazon or your local supply house. On Amazon, these are usually $10 or $15, so they're very affordable, easy to replace. Go ahead and just match the wires. There's going to be one common wire, that's a C. There's going to be an H wire, that's for the compressor, and a fan wire, which is obvious for the fan. As in here, I went ahead when this unit was running, I took thermal pictures just to see, make sure my contactor wasn't an issue. So the contactor is right here. So what that does is it actually goes to your thermostat. Your thermostat sends a 24-volt signal to the relay here, and this thing in the middle right here magnetically pulls in, makes the contact, and sends power to your compressor. That's the 240 volt power. So this thing actually is always engaged. Even when your unit's off, this thing is still connected to your thermostat. So if your thermostat tries to turn on this unit, it'll send voltage, 24 volts AC to here to turn it on. But other than that, most of this other stuff is fine. The board is very simple in here. There shouldn't be anything that goes wrong with that as long as everything's sealed up. And then all the rest of this is very simple. There's a wire, there's a set of wires that plug up to here for the defroster at the bottom of your compressor that keeps the oil warm during the cold times. Other than that, it's very simple. Just send power to the compressor, send power to the fan, have the capacitor to handle all the balancing of the load, and that's pretty much it as far as the electrical on your compressor. So when I was taking thermal images, I went ahead, took some thermal images of this to see what the compressor and everything was at when this thing was running. It didn't really get a very accurate temperature, but it at least showed me that the range that the top of the compressor was at, so that one seemed normal also. One thing you guys should always pay attention to is how impacted your coils though. Once you're looking at the unit, I did end up spraying everything off of here. There was nothing on here because I maintain it pretty well at my house, but just for shits and giggles, when I had the fan out, just diagnosing everything and checking all the wiring, I went ahead and just sprayed everything out and got everything clean just to make sure there was nothing inside the coils like pollen or debris or dust. So this capacitor, the last owner or the last technician changed out on my unit when it was about 4 years old. That was how long these capacitors actually last these days. So this one is actually a made in the USA universal turbo 200X made here in Florida. I suspect it's a very high quality one, but who knows with made in the USA these days. But what it is it's a universal one where depending on what you need as far as the farads, it's got every size on the side here. They actually have 2 or 3 5 farads because sometimes you'll need that both for your compressor and for your fan. So they kept 2 of those there. Then they have the 7.5, which is what we use right there. So it's just that terminal to the ground terminal or the common terminal in the middle right there. For the bigger side, depending on if you need 30, 40 or 50, you have these options on the side to kind of just add up to that much. So this particular unit, mine was a 70, so they added basically the 20 and the 50 together, and they basically jumped it in parallel, and then you hook up one of your wires from your compressor to there, and since it's capacitors in parallel, they actually add up. So right there you can see that's basically how these universal capacitors work right there. But for us at this point in time, this thing is 5 years old, almost 6 years old. Even though it still works and everything measures out right, I don't trust it to last forever. So I'm going to hold this as a backup in case the one in there ever fails when I don't have a spare, and then I'll just drop this in there, let it run until I order a replacement. Usually I keep one of these on hand in my house just because I know these things go bad in the middle of the night and you don't have 2 days to wait for it to come from Amazon. You'll also notice I mounted my capacitor upside down. These things can be mounted either way. They're fine because inside it's completely sealed, so it's not an issue whether it's upside down, right side up, or whatever. I did it this way because I didn't want water sitting on the top of that lid there and end up corroding that out and basically leaking. You saw the one I took out where it was turned the other way. Originally, when I first moved in this house 5 years ago, that thing was nice and silver on the top. And after 5 years of corrosion and moisture, you can see that that thing got really corroded on the top. So once we determined none of these issues over here, including changing out the capacitor, fixed my breaker issue, I went ahead and went inside, did the final diagnostics on the actual breaker itself using the thermal imaging inside the panel once I opened it up, and that's where we had our culprit. After I did all that other diagnosis, first thing I noticed when I opened this thing up, this wire right here, I've got it covered right now with electrical tape, but it looked like the insulation was starting to melt. And that was very concerning because if this insulation right here, it's rated to 200 or 300 degrees, when it starts to melt, that means something is really wrong with the electrical and there's high resistance for some reason in that wire. So with my house, I've got a CT on this circuit out there at the junction box or the disconnect where I can monitor the amps and everything. And that's the first thing I looked when this unit was running. My amps were anywhere between 13 to 16 amps, which is normal for an AC circuit. That's about 3,000 to 4,000 watts depending on how hard it's working. So that none of that looked out of the ordinary as far as the consumption and the electrical goes. So I thought it was a mechanical issue, so that's why I diagnosed it originally as a capacitor or a contactor issue. So to pop the breaker out, once you disconnect the power, basically you just grab these things right here, or you just get something to pry it, because all they do is snap in. There's 4 snaps on the back side, 2 that snap into the actual contactors and 2 that snap into the plastic back. I'm not going to show it on this video just because I already did it and I don't want to go ahead and pull this out, but you could probably watch videos on YouTube and they'll show you how to take a breaker out of the panel pretty easily. Yeah, but once I pop that thing out, unscrew that thing off of there, because once you pull that thing out, it's not energized anymore because all the energy is on these 2 lugs in the panel. Once you pull it away from there, that just goes out to the equipment. I unscrewed those things. This one, since it was starting to melt right around the edge there, I wrapped it with 3 layers of 3M electrical tape, the good stuff. One of those 2 electrical tapes that I only use now because that's the only electrical tape I trust. Since I didn't know what really caused that issue, originally the wire that got really hot, which is the current conducting wire, or the one that was having issues, was on the bottom. I ended up swapping it to the top just so I can actually balance it in case there was imbalance in the circuit for some reason causing that. So I just swapped it. Since this is a 240 single phase, it doesn't really matter which side you choose. All it does is switch between the red and the black here, but for the equipment it won't notice any difference because it's 240. So after we put everything back together, I turned the AC back on, I put the disconnect and everything outside back together, turned it on, watched my amps again. The amps were still the same, around 15 to 16 amps coming off of the unit when it was running full speed. I let this thing run for 20 or 30 minutes and I was checking the temperature while I was running, and then at the end there, and it stayed around 80 or 90 degrees the whole time, the wire, the breaker and everything, which tells me it wasn't overheating, it was running normal and there was no resistance or anything internally wrong with this new breaker. So that ended up solving my issue right there. So this was the original 10-year-old breaker that was in there. You can see right there sort of a little bit of discoloration where it got really hot on the lower lug right there. The top lug is a little bit more silver, but you could tell right here the dielectric grease that they had in there when the original electricians put it. You can see that thing got burnt and it's kind of discolored, and the lower one inside the holder is all discolored, and that's from the overheating right there. You can see some of the plastic on the outside looks deformed too versus the top. So that was obviously the problem that was tripping my breaker. I ended up also testing this one like I tested the new one as far as resistance between the lug here and then that lug, and they both showed 0.03 resistance. So that was not the issue either, because obviously the resistance is fine, but I guess high current resistance is what the issue was. So somewhere internally here, something must have failed. So I opened it up just to see what was inside, if there was anything that was obvious. And I really can't tell in here if there's anything that was wrong with the breaker itself that caused the overheating, because right here is the lug. So you basically send all the signal through here, or the voltage and the current goes through here, passes up through this. This is a trip right here, this little trip part goes through here, and then it comes into here, and then it makes contact. So that makes contact right there. So unless there was some kind of restriction that would have caused the thing to overheat, I just can't see it just looking in here. And this is the other side of it that wasn't overheating. Still, nothing in here suggests that anything is wrong or anything was shorting out that it would have caused this thing to overheat and not move the current fast enough, or resistance in the circuit. So took all the little bits and pieces apart, but nothing inside the breaker suggests that anything kind of failed, obviously, but who knows how these things really react inside to temperature and all that. But yeah, it could be just a slight little air gap or something could cause some arcing or some slow moving current that would eventually overheat the wire. But there you have it, guys. That was my diagnosis and my issue as far as what was wrong with my breaker. It ended up being a bad breaker, but obviously I have a little bit more technical knowledge, and I have all the different tools that help me diagnose this, especially the CT, watching the amps, and the thermal camera. But those type of things you can always get on Amazon if you need it. But luckily I had all that in hand, and we were able to diagnose this and then just change out this simple $40 breaker. But other than that, I mean, this should fix this issue for a while now. Thanks for watching me ramble on and show you guys how to diagnose and fix your tripping breaker. If you guys found this video useful, give it a thumbs up. If you haven't subscribed to the channel to stay on top of all my different DIYs around the house, on the car, in the garage, or whatever I'm doing, go ahead and like this video, subscribe to your channel, turn on bell notifications to get notified every time I upload. For all these different projects around the house, on the cars, or whatever I'm doing, if I can do it, you guys can do it. I want to thank you for watching, and I'll talk to you guys next time.